Now we will discuss the properties of magnetic lines of force. So, magnetic lines of force are generated, actually it comes out from a north pole to it moves from north pole to south pole from outside the magnet, and inside the magnet it moves from south to north pole. Clear? So from outside the magnet it moves from north to south, and inside the magnet it moves from south to north. We are discussing the properties of magnetic lines of force. Second very important point, they never cross each other. And you have to answer this question, why they do not cross each other. Because, now listen carefully what I am saying, they do not cross each other. Suppose they cross each other here. Suppose they cross each other here. So, every point around a magnet has a unique direction of magnetic lines of force, and if they cross each other, then you will have at the point of crossing you will have two different directions, because you can draw two tangents on that curve. And every point, if you want to find the direction of magnetic field here, so what you have to do, you have to draw a tangent, and the tangent gives the direction of the magnetic field. Now if two curves or two lines of force crosses each other, you can draw two tangents, one tangent here and other tangent here. That means you can have two different directions at the one single point, and which is a contradiction. As we know from the property of the magnetic field, each point has unique direction. So if they cross each other, you will have at the point of crossing you will have two different directions, which violates the basic law of electric field. Every point has unique direction of magnetic field, has unique direction of magnetic field. And so if they cross each other, at the point of crossing you can draw two tangents, and there is available two different directions, which violates the basic law of magnetic lines of force or magnetic field. Clear? So they never cross each other. They all have same strength. If the magnet, here is a single magnet, it has a pole strength north pole, south pole, and they have a fixed pole strength. And if the for a magnet, the pole strength, since the pole strength is fixed, so every lines have equal strength, because it is coming out from a single magnet. So they all have same strength because they are coming out of the same magnet. So same magnet cannot generate a different kind of magnetic lines of force with different strengths. So when the magnetic lines of force are coming out from a north pole or emerging towards the south pole, they will have all equal strength. So the third property is they all have same strength. Now fourth point is field strength is directly proportional to the density of lines. So you can see here that this is a magnet, and the density is not uniform. Near the pole, this is north pole and this is south pole, near the pole the magnetic lines of force are denser, and at the perpendicular bisector line of the magnet axis, this is your magnetic axis, and you can see that the density is not as much as we see near the pole. So here density is less and here density is more. So we can estimate the field. Field is more here and field is less here. Field strength is directly proportional to the density. If the density is more, field strength will be more. If the density is less, field strength will be less. Now next point is density of lines of force decreases as we move away from the poles. So as we move away from the poles, if we move away from the poles, the density will decrease, and simultaneously the field strength will also decrease. So as we move away from the poles, be it north pole or be it south pole, the density decreases, and as the density decreases, the field strength will also decrease. Now density of the lines as they move away from the poles. Okay, now sixth point. These lines of force accrue in lateral position. Accrue Hindi meaning in Hindi is falla. So this is your lateral position. The perpendicular bisector line is your lateral position. So in the lateral position, they expands. They expands, and in longitudinal position they contract. In longitudinal position they contract. So you can see here clearly that in this equatorial line, or what we say perpendicular bisector line, that is called lateral position. That is called lateral position, that perpendicular bisector line. So in this line it expands or accrue, and along the magnet these lines of force contract. So these are the 6 basic properties. You can add one more, seventh. I am telling you, seventh property you can also write if you wish. Seventh property is the tangent drawn at any point on the curve of magnetic lines of force gives the direction of magnetic field. So you can add seventh property also if you wish. Although 6 properties are enough, but I am saying if you wish you can add seventh property also. The tangent drawn at any point on the magnetic lines of force gives the direction of magnetic field. So this is a very important question can be asked. So a few more questions arises from these properties. You may be asked to write all the properties, or write 4 properties, or write 5 properties in your paper. Write the properties of magnetic lines of force, then you have to write all these things. And one more question: why 2 lines of force do not cross each other? This is one of the most important questions. And all these properties can be asked separately, and they may be asked some different questions. But if you know all these properties, 7 properties, you can answer any scattered questions too, if you are able to memorize all these 7 properties which I have discussed now. Clear?